Hello my friends, how are you? After a long time I am with you to demonstrate something new thing about Hypack. In my previous video I show you how to deal with tight correction in bathymetry data. Now in this video I wanna preparing a channel or design section through which we can extract the volume and also extract the cross section profile as well as something. Now before, let's talk less and work more, so move on to my work. Okay, I have to open my Hypack here. Okay. This is my Hypack window and this is the project I have working in the last session. So in that session I show you how we do our tight corrections in a bathymetric data. So after processing all the things, the tight corrected data is stored in that edited data files. So if I right click on it and then hit add file tab, then you can see the edit file is exist there. So then I open it. Okay, it load my edited file data, which is actually the tight corrected data. Okay, you can see this is the tight corrected data. Okay, now if some agent tries to dredge this portion, then there are lots of dredging activities going all around the world, so it is very much useful to perform this dredging with the Hypack, because it is too much user friendly and also it less tedious to do work. Okay, so before I move on, I have to designing our design section, or in simplest way this is called channel design of a design section. So I go to my Excel file and before I go, I have to ensure you another thing. Dredging is performed based on a center line. I think the center line is nothing but the dredging element. Actually it is more precise practice is it is just followed the middle part of the river, but the thalloc point may be shifted from this if it is a meander channel, then thalloc point is shifted towards the meandering channel, and there is some CS bank erosion, and the other side is occurring the filtration. So in this video I want to show you our center line first. A tentative center line is might be drawn through in that fashion. This icon is called the editor bar. If I click on it, then you can see there is a lots of editing shapes, just like line editor, matrix editor, polling sheet editor, and lots of things, XYZ collector. So if I click that line editor, then a window is pop up. So I want to move to the file tab here. If I open it, then it is also show the same thing, but I have to import some centerline points here. Centerline points have three parts. One is easting, northing, and the Z value, which is actually the design bed level. Most of the design section is the trapezoidal sections, which have a fixed bottom width and the center line at center level of that bottom width, and also the size, and also a side slope, which is which is may vary from 1:3 to 1:6. 1:6 is totally used for the C portion, and 3 and other things is used in the river portion. Actually it is a common practice, not it is the rigid rules. Okay, if I wanna import, then you can see I import such things in this fashion. I don't go in that fashion. I have to show you the simplest way how we generate our center lines. Before I go, I have to open my Excel. You can see this is my center line information. One is easting, northing, and the z value. Actually it is a straight channel, and my design level is also fixed. Actually in river case you can't fix this design level in that fashion. I demonstrate it here because I want to show you just a practice session. In reality river has also a longitudinal slopes, so for designing that we have to follow the longitudinal slope also. Okay, now this is my design information. So first of all I have to convert this into the XYZ files. So as I can demonstrate in the previously, the heading must be eliminated, so it is control minus. Okay, then I hit my file, then save as. I have to move it in that portion, then select the text tab delimited txt files, so in that version, then hit save. Okay, no problem. Then I move to the tools, and then universal input, and it is XYZ file. So hit this one, and then move to my data, then CL, then this. Okay, and then output file, it's a XYZ formatted file, so we'll just simply hit CL, site is KO5, then modify it. Okay, then hit save. Okay, now I have to see record field. I have to check all the things. It's a tab delimited file, and then simply hit convert. Okay, now exit. Now I move to my project files, and then sorted data files, and then hit add files, then go to my data, then CL, and look at this one. Just simply I off my data. Okay, look at this. This is my center line points. One is located in the downstream, and the other is upstream. So if I hit this, then you can see the more information. Okay, I think it should be clear to all how we display our center line in our Hypack window. Okay, now I move to the most important part, which is actually called the channel design. Okay, you can move through this preparation tab, hit this, and then there is a file name channel design. Just click it, and then you can see it's a depth moded file, and I have to click this tab file and then import, and I go to this shorted files. I can demonstrate small things. When we convert this text file to XYZ file format, and if I add this into the shorted file data, then it will automatically stored in this short folder. Okay, just click it. You can't see this because the file type is plain line files. If I check it, if I change it to XYZ format, then you can see the file is appear here. So just click open, and it displays the easting, northing, and the RL files. So now I have to chainage is most important. So from upstream to downstream we have to mark the chainage. Usually in common practice is upstream channel we have to fix it as a 0 chainage. So if I hit is type it 0 and then hit the changes button, then it will automatically calculate the rest of the portions changes. So it's a 1515 meter, that means 1515 meters total length of the center line. Okay, then I move to the left toe, and for simplicity I just use offset. Okay, click on the offset. It means that from center to the left portion it will create a channel, which offset maybe it's a I have to ensure one thing. What is the width of this channel? Actually it's a 400 meter width channel, so I wanna fix that at 30 meter bottom width of my channel, so that click offset 300 meter actually. So at one portion I will provide 150 meter, the slope is 1:6, and hit OK. Then it will automatically create a bottom toe line. Then similarly at right toe, click offset, and it will incorporate the all thing automatically. Hit OK. It also show you the right two portions, upstream and downstream, and the slope. Okay, now we move to the general tab. It's a depth meter file, and top of the bank is the most important thing. Top of the bank is how far I will take my slope to cut. It is actually the cut point of the last slope or the side slopes cutting edge actually. Okay, I can fix it. It's 8, so I will have to do this at 8, and this is 6, so 4. Actually it's a depth meter file, so if the lower number is indicates that it will moves to the upward direction. Okay, then it will be -2. It is also -2, and no extension is required here. And the spacing means what is the interval of my cross sections. So I simply hit it's 10 meter, and the naming format, the chain is naming format. I have to select this one and smart corner as it is described in my previous files, so I can't describe it here anymore. Then hit generate. Okay, you can see it automatically generates the design sections. If I want to view this, just go to view tab and then 2D view, then you can see the whole channel. Okay, that looks nice. It's a 0 changes, and then in the upward this is the last one. Okay, I close it, view, and if I want to see the sections, you can see the sections is also there. Okay, it's a 0 changes, and then you can see the channel is changing. Okay, now I close it. Now I save this and save to LNW. It is the actually my section file. I name it as design section. And then it also, I also say you are required to save this as also a plan file, so that if I want to modify something, then I have to just click this PLN file and then change my parameters a little bit. Okay, hit this one also design section, design file, design plan actually, design plan. So hit save. Okay, it. And now I move move to my project files and then go to my plan line files. This is my for temporarily I off my data, and if I check this design section, you can see the design section appears here, and if I check this plan line files, you can see also the plan line files. Okay, it's too simple. Okay, now if I double click on this design section LNW file, then you can see this is my design section LNW file. This is my start point and the end point. That blue line actually indicates the coordinate, that field blue actually. Okay, if I hit there, you can see this. Okay, and if I show you the template, this is the template of how section is designed here. Okay, look at this is my design section. Okay, it's a simple thing. And now I load these files. This is my data file. This is my data files, and now in this session I want to show you how we compute our volumes and also the design cross sections profile, how it looks like after dredged. Okay, so move that. I want to show you, go to the final product and then hit the tin model, because we have to make a tin model of this all things data to project all the data in my cross-sectional file at a specified interval. Okay, now hit this new main input files, then it will be the log file. So move on to my log file, to my project short edit data, this one. Okay, now the section files which I prepared sometimes ago, the design section is my section files. Then open it, change it to depth mode, and this is the tin maximum side. Tin maximum side means how long my tin leg is spread out. Okay, just like if I have sections at an interval of 50 meter, if I hit the tin maximum side is 20, then there is no tin formation in between these two sections. So I have to provide a safety margin. If this is 50 meter interval of cross section, then I have to set here minimum 55 meter of tin maximum size or something more. There was some back effect of this. If I set a too large distance, then it will also take the unnecessary data which is not desired. Okay, first of all I have to see what is the interval of this data. Okay, just see, it is actually 25 meter. I think yes, it's 25 meter. So I have to set this at least 50 meter. Okay, it's a depth. Let's check it and then hit OK. You can see model is generated. Okay, then click the modify to see how it looks like the tin model. Okay, you can see it builds the tin model. Okay, I'll close it, and now I go to the export options and then hit all format. You can see the line number, and there is 1 to 152 cross sections there, and I have to, if I set a specified point duration, then it will extract the points at an interval of specified point. Okay, so that's one spacing. Actually I set here 5, that means in my design section it extract data at an interval of 5 meter along the cross section. Okay, now output files, and then it is also an edited file, so I have to save it in a new folder. Design section, to name it design section. Save, and then if I click export, then it will automatically export the data sets from my tin model actually. Okay, look at that. This is the data which generated on the cross section files. Okay, now I close it, close this also, and finally I move to my final product file, and then the cross sections and volume. To click on this, there are lots of methods in this volume competition, just like Chinese on interior 3, interior 1, interior 2, 3, all things I have to explain in my later videos, but for simplicity I have to select here interior 1. Okay, and I just see what is the parameters setting there. Data is elevation mode, so I have to change it to depth mode, and template element is center line, it's okay, and then view. Okay, now I have to reload the files that I generated in my immediate session. So this is the design session log file. Okay, imported the files, and if I want to see the view, okay, the first session is incomplete because there is no data. If I move forward, okay, you can see the cross sections. If I enlarge it, you can see the full cross sections, and this is the red portions is my dressed portion actually. Okay, I have to, its the minimum value is -5, change it to -2, then it looks a little bit more clear to all, and it is 8.5, and I have to set this maybe 10 should be okay. Okay, now you can see in the files lots of volumes in these sessions. Okay, now I want to see my last section. Okay, these are also incomplete because there is no data available in particular these sections. Okay, so now that's all from today's video. In my next video I want to show you how we will make volume report, and also how we calculate these volumes from this interior method actually. Okay, till now it's goodbye to all, have a nice day, bye bye.